Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 11.2, Operations with Radicals. Before we get started with the operations with radicals, let's talk about the review of rationalizing the denominator. In this case, we have an example of 2 over the square root of 5. Obviously, what they're going to do there is they're going to multiply by the square root of 5. This allows us to get to a perfect squared radical denominator, which is the square root of 25. The square root of 25 turns into 5. Notice, anytime that I multiply something by the denominator, I must also multiply it by the numerator, which means 2 times the square root of 5 just stays 2 square root of 5 all the way through. So let's go ahead and take a look at A real quick. What we'd have to do is exactly the same thing the example did. I'm going to multiply both the numerator and the denominator by the square root of 5. That leaves me with 5 times the square root of 5, which is just 5 root 5, over the square root of 5 times the square root of 5 is the square root of 25. At this point, I need to simplify anything I can. So the square root of 25 can be simplified. My numerator is going to stay the same, 5 root 5, over the square root of 25 becomes just 5. Now, if I have anything in the numerator that matches anything in the denominator, I can go ahead and simplify it. So the 5's will cancel, leaving me with just the square root of 5 as my answer. Okay. The same thing can be done with B and C. If you need any more work with the review of rationalizing the denominator, please come in and have a conversation with me. Let's go ahead and move on to our operations. So example 1, we're going to go ahead and combine like radicals. This is no different than combining like terms. If the radical is exactly the same, the example we have here is the square root of 2 plus 3 times the square root of 2, then what I can do is go ahead and just add the numbers that are in front. So I have 1 times the square root of 2 plus 3 times the square root of 2 is equal to 4 times the square root of 2, and that is fully simplified. This is no different than if I had x plus 3x. Well, x plus 3x we know is 1x plus 3x, which equals 4x. You can treat radicals that are exactly the same just like variables. Okay, so let's go ahead and look at A. Are our radicals the same? Well, the square root of 5 is the same as the square root of 5. So I'm going to go ahead and take negative 3 minus 4. Well, negative 3 minus 4 is negative 7. What's left from the radical is just the square root of 5. I will not change the radical at all. It is already the same. They're already like radicals. So I can go ahead and keep them the same. On B, if you do not have a number out front, remember that it will be a 1. So I have 1 root 10 minus 5 root 10. The radicals are the same, being that they are root 10. So I'm going to take 1 minus 5, which is negative 4. Root 10 is going to go ahead and stay root 10. Last one, C, we have 4 root 3 minus nothing root 3. Well, minus 1 root 3, so it'll be 4 minus 1, which is 3. Root 3 will just stay root 3. What you need to remember is if these radicals can be simplified, you need to go ahead and simplify them. Even if they are like radicals, you need to go ahead and put them in simplest form. So let's look at example 2, where we will simplify to turn them into like radicals, which will allow us to then combine them like we just did on the last section. So the first example, I have 7 root 3 minus root 12. Well, that tells me that that I cannot combine them. I can't just take 7 minus 1 at this point. What I have to do is turn that root 12 into a root 3. Well, how do I do that? Well, I'm going to take the square root of 12 and break it down into a perfect square and a non-perfect square. So the root 12 will simplify into the square root of 4 times the square root of 3. The square root of 4 is 2, so I end up with 2 root 3. Notice I want to turn that root 12 into a root 3. That's what I'm looking to do. So what I can do always in this situation is try to take the larger square root, in this case root 12, divide it by 3, see if it comes out to be a perfect square or not. In this case, if I take 12 and divide by 3, I end up with 4, so it does work out for me. Now that I have 2 root 3, they put it in for the root 12. They take 7 minus 2, which is 5. So 7 minus 2 is the 5. The root 3 stays the same, just like the section above. Let's go ahead and look at an example ourselves. We have 3 root 20 plus 2 root 5. So I want to turn the 20 into root 5. I know I want to turn the 20 into root 5. So what I need to do is break the 20 down. So it'll be 3. I know that one of them, we want it to be root 5. So what is 20 divided by 5? Well, it would be root 4. I can just leave the 2 plus root 5 coming along next to us. Now, what can simplify from 3 times root 5 times root 4? Well, root 4 is a perfect square, so I can take 3 times 2, leaving me with my root 5, plus 2 root 5. That's just going to keep coming along. Well, 3 times 2 is 6 root 5 plus 2 root 5, and now I have problems just like, or I have an example just like what I was working on in the last section. So I can just take 6 plus 2, which is 8. The root 5 and the root 5 will just stay root 5. And I'd be done. On to B, I have 3 root 3 minus 2 root 27. We have to think about what we want to turn the root 27 into. Well, root 3 is our key. So I have 3 root 3 minus 2. How do I break 27? I can break it into, obviously, 27 divided by 3 is going to be the square root of 9. So 27 divided by 3 is 9. This allowed us to have the root 3 that we're looking for, and it's a perfect square root. So I'm going to take 3 root 3 minus 2 times the square root of 9 is 3, and then root 3 will be left over. So I have 3 root 3. I need to multiply the negative 2 and the 3. Turns it into negative 6 root 3. Well, just like in the section above, now that I have the square root of 3 and the square root of 3, I can just do the operation of the numbers in front. So 3 minus 6 is negative 3. The root 3's will stay root 3. On to the last problem. I have 8 root 45 minus root 45. This is an example of what I was talking about in the section above, where right now, because my square roots are perfect, I can take 8 minus 1. Well, 8 minus 1 is 7 root 45. I need to double check to make sure that my radical is in simplest form. Well, 45 can be divided into a perfect square 9 and a non-perfect square 5. So I can take 45 and split it up. If I can do that, I need to do so. So now I can take the square root of 9, which is 3, and keep the square root of 5. So 7 times 3 is 21 times the square root of 5. The most important things to remember here are that we can add like radicals, just like we can like variables. Also that we need to write our answers in simplest form. So we always need to double check our radicals to make sure that they cannot be broken farther down into a perfect square and a non-perfect square. That is our lesson for today. Make sure that if you do not understand something, that you come in and ask questions, or ask questions when we're going over the notes. Thank you very much for watching the video, and have a great day.